Okay, so we're going to review factoring polynomials. Polynomial, that just means we have more than one term. This is a review, which means I shouldn't, hopefully, be teaching you anything new, but it might be some strategies that you haven't used in a while or whatever, but things that we need to know. So we're going to start with GCF. Okay, we're going to start very basic. GCF, there is a difference between greatest common factor and just a common factor. Okay, because let's say that I had this was my numerator and it was all over 2. Then if I wanted to reduce it, I could just factor out a 2, be able to reduce by fraction, and that's good enough. That's a common factor, but not a greatest common factor. But if you're asked to factor out the greatest common factor, or you need to reduce it more for yourself to help yourself more with whatever else you're going to do it, we need to make sure that we can actually get the biggest out of there. So when I look at 24 and 54, what's the biggest number I could divide out of both of those? 6. Y'all agree with that? Now, I'm actually doing the same thing in pre-cal as well. And we did this part yesterday. And yesterday somebody told me 8, because 8 is bigger than 6 and goes into 24. But does 8 go into 54? No. But if you're like me, which hopefully you're not in this case, I was the last person in my 3rd grade class to know my multiplication facts. Clearly, I'm very traumatized if I still remember that. But 54 and 56, like I still have to think about them so I don't say the wrong numbers or I get those mixed up. But just a couple years ago, one of my teacher friends was like, I made that comment or whatever, and she was like, well, I remember 56 because it's 5, 6, 7, 8, and 7 times 8 is 56. I'm like, that makes so much sense. So now I still have to think about it, but I think that, and then I'm pretty sure. Plus 4 plus 5 is 9, and then that 9 divides into that one. So that's 9 times 6. So just kind of giving you some hints on how to remember those facts. But 6 is the biggest one that comes out. So we're going to factor out a 6. And then how many y's get to come out? 3. So then what I'm left with, 24 divided by 6 is 4. I have 1 y left. Then that's still minus. And 54 divided by 6 is, what did we just say? 9. 9. And then all the y's were gone. And so then we're done. Okay. And then you can always check yourself by, if you distribute that back in, you should get back where you started from. The biggest hurdle to factoring really is knowing your multiplication facts. And I mean, it's okay if you're not like super quick at it, but if you can't manipulate the numbers in your head to figure out different factors, then it just makes the whole process even more difficult, even if you know the steps and what to do. All right, so let's look at number 2. When I look just at the numbers, 17 is definitely a prime number. Is 51 a prime number? No, because we know it's divisible by what? By 3, because 5 plus 1 is 6, right? So by looking at that, because once the numbers get bigger, small prime numbers you probably recognize. Like, 13 is a prime number. If I ask you if 293 is a prime number, with you just thinking about it, you might not have any clue. I don't either. I just made up the number. I'd have to think about it for a second. But I do know I can check, okay, obviously not divisible by 2, but is divisible by 3. And guess what 3 times 17 is? 51. So, and you could, if you had to guess and check and play with things, but if you know it's 3, try 3 times 17, because if 3 times 17 is not 51, then you can't factor anything out, right? So either way, you don't have to check a bunch of numbers. All right, so I'm going to factor out a 17. How many A's come out? 3, good. How many B's? 4, okay. So then what I'm left with is 3, and then a to the what? 5th, because with exponents, when you're multiplying the bases, you add and subtract the exponents, right? And then I used all the B's in that one. Plus, I took out the 17, I took out all the A's, and I'm left with just B. One of the things on our list is to go back over exponents as well. You didn't understand this question at all? Okay, so do you understand how the 17 came out? No? Okay, because I can divide each one of these numbers by 17. 51 divided by 17 gives me 3. 17 divided by 17 gives me 1. So if I multiply it back in, I do 17 times 3, that gives me 51. 17 times B, there'd be a 17 there, okay? As far as the variables that come out, if I divide, let's see, I had let me do it this way. Let me do 51 a to the 8th times b to the 4th plus 17. Because I think some teachers, I mean, I don't know that I've ever taught this from scratch. It's always been a review thing in everything I've taught. But if I divide this, basically I'm dividing each term by the GCF. 17 a cubed b to the 4th, 17 a cubed b to the 4th. Okay, does that make more sense? And I think some teachers kind of show you to do that here. So when I do that, that leaves me with the 3. And then because I'm dividing these, I subtract the exponents. So 8 minus 3, that's what gives me 5 left in here. And then those cancel out completely. Then here the 17s are gone, all the a's are gone, and then b to the 5th divided by b to the 4th is b. Okay, does that make more sense? Okay, good. Thank you for asking. Don't be afraid to ask. I can re-explain it many different ways if necessary. We all good now? Okay. Now, before we talk about straight up factoring and getting our 2 binomials and stuff, we're going to talk about some of the special cases. The first one, and the one I think, in my opinion anyway, is the easiest, is a difference of squares. So let's talk about perfect squares first. Your perfect squares would be like 1, 4, 9, 16, 25, 36, and so forth, right? Oop, that's a 26, 36, and so on. Okay, those are just perfect square numbers, because that'd be 1 squared, 2 squared, 3 squared, 4 squared. So your rule for factoring, if what you have in front of you that you can factor looks like a squared minus b squared. So that's what makes it a difference. Okay, they're being subtracted. And I can take the square root of this one and the square root of this one. Now I can actually take the square root of anything, but I mean square root and have a whole number or something left there. Now we're going to do, 2 different cases here, but one of the examples I also want to do with you is x squared minus 49. So we'll start with that one. But do you see how this is a perfect square and this is a perfect square, right? So that's what makes that a difference of squares. So the first step in solving these is recognizing that that's what you have so that you know what to do. Your rule for that, you end up factoring it into 2 binomials, which would then be a plus b and a minus b. Okay. So again, it's the easiest because you don't have to do anything. You don't have to guess and check numbers, anything like that. So if this is a difference of squares, I'm going to have 2 binomials. I know one will be plus, one will be minus. The square root of x squared is x. What's the square root of 49? 7. So I get x plus 7 times x minus 7. And it's factored. It's that easy. Okay? You just take the square root of the first term, square root of the second term, you get a plus, you get a minus, you're done. Okay? Any questions on that? That look familiar? Even if it's been a minute? Okay. All right, so then let's do this one. I'm going to have, I know this, I can take the square root of each one. They're both perfect squares, so I'll have a plus and a minus here. So what is the square root of 36w squared? 6w, very good. So 6w goes first, and the square root of 25 is 5, good. And then that's it. Okay. Any questions on that? We good? Yes? All right, so here, these are perfect squares also. I know you don't like it, but we'll survive. So I'm going to have a plus and a minus. I know the first one's a fraction, but it's not that bad. What do you think the square root of 1 over 144 is? 1/12. Very good. So because the square root of 1 is 1, so that's my numerator, the square root of 144 is 12. So that's 1 over 12. Now, when you take the square root of the variables with the exponents, if the exponents are even, it makes it very easy. You just divide the exponents by 2. So the square root of, right down here, the square root of r to the 6th, s to the 4th, you just divide both exponents by 2, so you'll get r cubed s squared. Dang it, maybe it'd help if I use the right letters. R cubed s squared. Okay, everybody okay with that? Because again, I know we haven't gone over exponents, but whichever one we go over first, there'll be something else we have to talk about. So this is r cubed s squared, and again 1 over 12 r cubed s squared. Okay. Any questions at all? We're good? All right. Now, there's a difference of squares. There is no sum of squares. If I had x squared plus 49, I couldn't do anything with it. I wouldn't be able to factor it. Okay, I can only do the squares if it's minus. We're going to talk about cubes. I can do sum and difference of cubes. I can do them both. But with difference of squares, it doesn't work that way. Okay. So let's look at cubes. These don't come up a lot. I know you've learned them. You may not have spent a ton of time on them. And when they come up, because they don't come up that often, we need to know what to do with them without stressing out or wanting to quit or making things up or trying to use photomath or, you know, all that stuff. So let's talk about perfect cubes. Your perfect cubes would be like 1, and then 2 cubed is 8, 3 cubed is 27. No. Yes, Eden? Do they need to sign for it? Eden, right? Who saved your life by bringing you this? Your dad, so you better be nice to dad today, right? No teenage attitude? Okay, be respectful, always, but especially today. Thank you. All right, so 2 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216. I would say knowing your perfect cubes, or at least being able to recognize them, up to 6 cubed can be helpful in your factoring life. Okay. Now, I don't want you to think about these two as 2 different rules, even though technically there's 2 different rules, because they're almost identical to each other. So we're going to talk about them at the same time. If I have a sum of cubes, the way that I recognize that is I would have a cubed plus b cubed. Okay. 2 perfect cubes added together. Difference of cubes would be a cubed minus b cubed. Okay, so that's what they look like. And also the questions themselves, these are sums and difference of cubes. So that's just the generic, you know, variable way to do it. Y'all are falling apart. All right. And so again, when these are going to be the same type of thing. We're going to fill these in both at the same time. When you factor a sum or difference of cubes, every time you're going to get a binomial, which means I'm going to have a 2 term in these parentheses, times a trinomial, 3 terms, both times. Okay. Then the pattern for the terms are going to be the same in both. We'll worry about the pluses and minuses after we get the other terms in there. So y'all are falling apart. My goodness, I just need to like throw some allergy medicine out there and sprinkle it on you. The cube root of a cubed, so I take the cube root of this and I get a. Take the cube root of this and I get b. Okay, that happens in both of them. So it's kind of like what we did for difference of squares, right? We took the square root of each. Here we take the cube root of each. All right, so then the way I get the rest of them, I take this first term and I square it, a squared. Then for my middle term here, I multiply the 2 together, a times b. And for the last term, I square that second term. I'm going to make sometimes I don't make my parentheses big enough. It's just a little bit bigger so you can read what I'm writing. The same thing happens down here. I square a, I multiply them together, I square b. Okay. So do you see so far how everything is identical, right? That pattern is exactly the same, whether it's the sum of cubes or the difference of cubes. There's an acronym to help you get the signs in there correctly. Does anybody know what that is? Has to do with Washington. Not SOHCAHTOA, but that's okay. That's an acronym you know. So at least you know what an acronym is. Good job. It's okay. Y'all might not know, which is probably why you hate factoring these, because you just have to remember patterns. But acronyms help, of course, only if you know what they stand for. But the acronym is SOAP. Anybody heard the SOAP acronym that goes with that? Sure, you were close. That's some of the same letters, right? Okay. So here's what this stands for. S stands for same. O stands for opposite. A stands for always. P stands for positive. So once you get the terms in there, then we worry about the signs. And the way we figure it out is same, opposite, always positive. Okay, that's what that means. So here, this is the sum of cubes. So the first sign right here is the same. It's a plus, just like this one is. The next one is the opposite. The third one is always positive. So if I'm doing difference, first one is same, so it's minus, then opposite, and then always positive. So the only difference between sum and difference factoring is with the signs that go in between the terms. Okay, so look at that for a second. I want you to see how it's really just one big rule, not two completely different rules that we have to remember, because then that's less that you have to get stuck in your brain. We good so far? All right. So again, the first thing I do is identify that this is a sum of cubes. This is a perfect cube. This is a perfect cube. So I'm going to have a binomial and a trinomial. And I highly suggest, again, I'm never saying you have to do it exactly my way. I highly suggest you do this exactly my way. This is what I would do myself if I was factoring this by myself, not just because I'm teaching it to you. I'm going to take the cube root and get h. What's the cube root of 125? 5. Okay. Then I'm going to fill in these terms. I'm not worried about the signs yet at all. H squared, multiply the two together, 5h, square 5, get 25. So I make sure that pattern of the terms is correct first. Then I think SOAP. This is plus, so it's the same, opposite, always positive, and it's factored. And for, I would say, probably the most of the sum and difference of cubes that you come across, especially now, you won't be able to factor this anymore. Now, is it possible? Yes, it depends on how complex your original one is, but I don't think we're going to have any crazy complex ones. And even if you did, I don't know that you would be expected to continue factoring unless you were doing some more advanced stuff with it. It doesn't happen that often, so we're just going to say, oh, I'm done. I really can't do anything else. Okay. So let's try 8. I'm going to have a binomial and a trinomial. All right. What do you think the cube root of 8f cubed is? 2f. Good. And the cube root of 27? 3. Okay. Now, when we go to our little trinomial and we have to square that first term, like here, I'm just taking this and it becomes h squared, and that's what goes in there, right? So I need to take this 2f and I need to square it. What I don't do is just put a little squared on it right there, because it's the entire term that has to be squared, which means that's really 2f times 2f, and what is that? 4f squared. Good. So this is really 4f squared. Okay, everybody understand where that came from? Think about that when you're squaring, that you're actually squaring the entire thing. The middle term, I multiply the two together, so what would I get? 6f. Very good. And then my last term would be 9. Then put your signs in there. Same, opposite, always positive. Same, opposite, always positive. I multiplied, so to get this term here, I take these two and multiply them together. So it's 2f times 3, and that's where this 6f comes from. Good question. Anything else? We're all good? Okie dokie. So then let's look at this difference down here. Cube root of x is x. What do you think the cube root of 343 is? It is 7. Now, yesterday, was that just a wild guess? You knew it. Okay. So yesterday, when I asked that in one class, like nobody really knew, but they were throwing something out. So somebody was like 13, because I mean, you got to start somewhere, right? I said, all right, so let's say we thought maybe it was 13. When you go to 13 times 13, we should know that that's 169. If I have to multiply by another 13, even just multiplying by 10, I'd be like in the 1600s, right? Way bigger than 343. So clearly it's not 13, but because that would give me into the 1600s, would I want to try 12 or 11? No, it kind of tells you need to back down more, right? And then you could eventually get to 7 if you had to guess and check, but it's not 13. Okay, and then so this would be x squared. What's the middle one? 7x, good. And the last one is, 8 times b, good, 49. Okay. Then you worry about the signs. Now, the cube root of negative 343 is negative 7, but I don't want you to think about that as a negative 7 in there, because then that's going to cause you to do weird things in the middle and whatever. So you get all that stuff in there, then you worry about the signs. And this is minus, so it's same, opposite, always positive. The sign mistakes I see on these usually are from people overthinking what's happening there. That's why you just put the terms in there, then put the signs in there, then you're done. Okay? All right, let's look at this one. Now, another mistake that I see a lot is, I know we all feel a little bit comfortable, or most of us probably do, with our variables being first. The variable is second here. You don't get to flip it around because you like it better. Okay, it has to stay that way. Otherwise, sign mistakes can totally happen. So I do just the same thing I did before. What's the cube root of 125? 5. And that one's first, so it comes first here. The cube root of 8v cubed is 2v. Okay, and it goes second. And that's fine, right? Then put in your 3 terms in the second one. Let's make sure we agree on those. Do we agree with 25 and 10v? Yes. And then what would the last term be? 4v squared. Good, because we got to square the whole thing, right? Yeah, I know. That's where it'll get you. Why do we do that? Because this it's a squared and b squared. So a is 5, right? So it's just 5 squared. This whole thing is b. So b is 2v, b has to be squared, so you have to square the whole thing. Oh, no, because if you flip them around and then we put our signs in there, the sign's going to be wrong here. Yeah. So just do it exactly like it is so that we don't make any mistakes, right? And then same, opposite, always positive. Okay. Any questions on any of those? We good? All right, so this is where we're stopping today. Your Delta Math assignment has just this stuff on it for you to practice a few. It should go hopefully fairly quickly and simply for you, but ask me if you have questions. Okay, and the back we're going to do tomorrow. We'll finish that up tomorrow.